Hello, it's Aristotle speaking. In this tutorial, we are going to explore the world of Scalar functions using Entity Framework Core and ASP.NET Core Web API. I'll show you how to migrate your Scalar functions using Entity Framework Core and also how to call these Scalar functions using Entity Framework Core along with ASP.NET Core Web API. So stick around, let's get started. First things first, let's start from our ASP.NET Core Web API template. On our solution, let's right-click, add new project, and from the template list, let's select our ASP.NET Core Web API. Okay, let's hit next, and let's call it Entity Framework Core with Scalar Functions API. And let's hit next, and let's select the default generated stuff from here, and let's hit create, and here is our Entity Framework Core ASP.NET Core Web API template. And now I'm going to install our required packages using NuGet package. So tools, NuGet package manager console. Let's install package. Let's zoom a little bit. Microsoft entity framework core SQL server. Great, let's hit enter, and the next package is going to be our Microsoft Entity Framework Core tools to work with, add migration, update database, etc. Let's hit enter, and here we are. What I'm going to do, I'm going to work with AdventureWorks 2019, but it is up to you to use database. You can use any database, of course. This is just a simple example. So I'm going to add a new folder for our database. So database, and let's right click, add new class. Let's call it AdventureWorks DbContext. First, we need to create our DbContext to work with Entity Framework Core. Okay, let's inherit from DbContext. Great. And for dependency injection, I am going to use DbContext Options Builder, AdventureWorks DbContext Options Builder, and let's call basis DbContext Options Builder, and let's do it this way to format it a little bit. Great. And let me show you our database. This is our database, AdventureWorks 2019. And here we have special database called sales.sales.order.detail. Okay, so you see we have sales.sales.order.detail. I will create a special Scalar function to get some information from this sales order detail. So that's why I need to connect to AdventureWorks 2019 and also to interact with this table. Okay, cool. Now let's go to our application settings. Let's add connection strings. This is going to be our AdventureWorks DB. Okay, this is our data source that initial catalog AdventureWorks 2019 integrated security is going to be our SSPI because I'm using the local connection without username password, and trust server certificate equal to true. I guess that should be okay. Now let's go to our program CS and inject our DbContext. So let's builder services at DbContext. Thanks to Visual Studio, it is automatically detected. So let's add our DbContext, and this is our using stuff. Great. Let's check our app settings. It is AdventureWorks DB. In our program CS, it should be AdventureWorks DB. Great. Now we have all the required stuff from the connection perspective configured. And now let's switch to our Scalar function. First, I will show you how to create this Scalar function using Microsoft SQL Server Management Studio, and then we'll migrate it from Entity Framework Core. Now let's go to our SQL Server Management Studio, and here I'm going to connect to AdventureWorks, and let's see what we have in our AdventureWorks sales order detail table. So you see, we have multiple columns with a lot of rows here, and I have special offer ID. This is a foreign key to our special offer table. I'm not going to use in the join or other type of join stuff. And I want to get total price of unit prices based on special offer ID. Okay, the purpose of our function is to accept this special offer ID as an argument and sum all the required unit prices based on this special offer ID. So let's create our function together. So to create our function, I will use create function. Let's call it UFN get total unit price by sales offer ID, and let's specify our special offer ID as integer. Okay, let's do it in this way. Great. So this is our signature. We have function name and we have only one argument which we are going to specify to get the total unit price. Okay, and returns decimal 16.2. This is our precision. This is our scale. For now, for testing purpose, you can just specify decimal because decimal is going to be 18.0 precision and scale. But let's correct it a little bit. Decimal 16.2 as, and you can also directly specify begin end or directly return response. So I will use the begin end stuff here. This is a bit simple to understand. So first I'm going to get a result. Okay, decimal 16.2. And let's select our information. Select, we'll use sum unit price where our so that special offer ID equal to specified special offer ID, and we will get response to our result, and at the end we will return our result. This is a really simple function. Okay, let's just execute it. Great. Now to call our function, we should just call function name directly using select, of course with schema. So we have DBO, and let's provide, for example, 1. Okay, let's try to get response. So here we are getting our response. So 2, let's see. Yes, everything is working. Great. Now let's just for now drop our function. Why? Because I'm going to migrate this function from Entity Framework Core. I always prefer to create function using ID of SQL Server and then just copy it because it is really easy to do it here. In our Visual Studio, we should provide string-based information, so it is a little bit to format, a little bit complex to understand all this stuff. If you have more complex stored procedures, views, functions, and that's why I always prefer to create it here to test it and then migrate from Entity Framework Core. Great. Now we have our function. I'm just going to drop it. So you see, we removed our function. Let's try to call it again. So it shouldn't work because we don't have the given function. Let me just run it, and here we are. Great. Now let me just copy this stuff from here. As you already know, in our previous tutorials, we worked with user defined functions like table valid functions and also with stored procedures. So we are going to implement a same path. That's why I'm going to use tools, NuGet package manager console, and let's call add migration initial. First, I'm going to migrate to create empty migration, and then I will fill all the required function skeleton into our migration file. So you see we have up and down based methods here. Okay, cool. Let's call it migration builder, SQL, and let's paste our function. Great. Okay, now let's do a little bit formatting here, and for the down, let's call migration builder SQL, and let's just call our drop function. Okay, I'm going to take it from here, to copy it from here. Okay, paste it here, and here we are. That should be all about function migration. So let's go tools, NuGet package manager console. Okay, and from here let's call update database. First, let's check if select is working. For now, we don't have this function. It is not working. So let's hit enter and wait our function to be migrated. So let's go to our select again. And here we are. Migration is done. That's how we are migrating our functions from Entity Framework Core to SQL Server. Great. Now we are planning to call this Scalar function. We already know how to call our table valued functions. They are really easy, but a Scalar function is a little bit different because it is not possible for you to directly call it, but you should specify your Scalar function inside your link queue to map it to SQL Server's queries. Okay, so cool. Now let's go to our we already did our add DbContext, everything is okay, and let's go to AdventureWorks DbContext. What I'm going to do, I'm going to specify my function like I did in our previous tutorial related to our table valued functions. So my function name is UFN get total. Of course, you can rename it, but first let's specify it. We have integer sales offer ID, and here you should throw exception because we have Scalar method here, and runtime our application, our code will be mapped to SQL's function. That's why you can return 0. I don't know, you can just throw any type of exception you want. That's completely okay, because when you run it, system in runtime will automatically map it to SQL's function. Okay, great. For now, we are throwing not implemented exception. That's completely okay. And let's go to our mapping side. I'm just going to override on model creating. And in on model creating, we have model builder has DB function, and for has DB function, I'm going to specify my AdventureWorks DbContext, and we have get method. So I'm specifying my get method. For my get method, I need to provide argument. For now, we have a list of arguments, but I should specify only one of them, but the signature requires a list of them, so that's completely okay. New, and we have type of integer because we have only one argument here. That's why I'm specifying type of. And what else? Of course, if you have completely different name, you can specify it. For example, my function is UFN get total unit price, but I want to call it without UFN. Okay, so that's how we are mapping it. So you have has name method. You should specify the exact SQL function name here, but you can map it to any named local function defined in your DbContext or in your static. You can specify it in your different classes as a static method. For now, we are using the classical implementation. Okay, and let's go to our DbContext. As we learned before, we it is not possible for us directly call this function because it will not work. You should specify it inside your link queue. For this link queue, I need to get some sort of DB set to filter our information. And that's why I'm going to create our sales order detail table using my DbContext. So right click, add class, and this is a sales order detail. You can use Fluent API, or for now I'm just going to use my table schema sales. That's cool. And let's go for it. Public sales order detail ID, sales ID. Don't directly focus on using the stuff generated by our Visual Studio because we have some issues here. For example, let's go for it. We have product ID. It is integer nullable, but here it is not nullable. So product ID should be nullable. Okay, great. So for the order QTE, we have integer, but it is small int. So I'm just going to remove this stuff. It is not important for us right now. So for our unit price discount, okay, and line total. Let's see our line total. It is computed numeric, it means it is decimal. Great. Now everything should work for now. Let's go to our AdventureWorks DbContext. I'm going to use public db set. This is our sales order detail and sales order details. Great. There is no need to additionally configure this sales order details. Great. And the last thing here is I'm going to create our controller. We already migrated our SQL function. Now let's call our SQL function. So let's implement our controller, right click, add, let's select our class. You can directly select the controller template, but anyway, AdventureWorks controller. And let's inherit from controller base. Great, let's specify our API controller and let's specify our route with API controller. Yeah, let's inject our AdventureWorks DbContext and let's specify our private read-only. Let's generate it. Great. AdventureWorks equal to AdventureWorks. I will specify only one single HTTP GET method here. And this method will return async action result, and it is going to be action result. It is going to be enumerable sales order detail. You can use your DTO, but I'm directly using our sales order detail and get sales order information asynchronously. And I'm going to call our AdventureWorks DbContext dot sales order detail, and to apply our function I will use a bit different syntax, not method based but query based syntax. Var response equal to from sales order detail in sales order details, where our AdventureWorks dot get total unit price. So you see in our link queue query we are going to use our function. That's where we are calling our exact function, and I should specify sales offer ID. So you see we don't have sales offer ID. That's why let's go to our model and specify public integer sales offer ID get set. That's all. Now specify our sales offer ID. Great. Let's select our SOD, and I'm not going to get all the information. That's why I will take only this is our async operation take only, let's say, 10 elements and to list asynchronously. Yeah, we're only missing the filtering stuff here because we should specify which value we want to expect. I want to see the total unit price greater than 10,000. Okay, 10,000. And let's take 10 elements with to list asynchronously, and at the end let's return our response. Great. Now let's rebuild and see if we have any issues or not. Great. Let's go start without debugging, and here let's specify API adventure works. Okay, let's hit enter and let's wait for our response. So you see we have sales offer ID here. Let's go to sales order detail. We don't have sales offer ID. So you see we have special offer ID. Sorry, it is special offer ID. And great, let's replace it with special offer ID. So our method name also should be changed by special offer ID. Great. So you see I have specified sales offer ID. This should be special offer ID, but anyway, this is not important. Okay, cool. And get total by special offer ID. Let's debug, start without debugging, and see if it is possible for us to get the required information. And let's refresh, and here we are. This is our information based on our function filtration. That's how we are interacting with our entity framework. That's how we are migrating and calling our Scalar functions. Well, that's all. If you like my videos, please don't forget to subscribe, hit like button, share, and I will see you in the next tutorials.